I'm not sure who needs to hear this, but snapshots are not backups. And in this context, I'm talking about virtual snapshots like what you do with a storage array. We're not talking about cloud snapshots like what you do with EBS volumes in AWS. If you don't know the difference, or you can't articulate why these snapshots are not backups, well, have I got a podcast for you. Hi, I'm W. Curtis Preston, aka Mr. Backup, and my podcast turns unappreciated backup admins into cyber recovery heroes. This is the Backup Wrap-Up. Hi, and welcome to the Backup Wrap-Up. I'm your host, W. Curtis Preston, and I have with me my Spanish language encourager, Persona Maliandi. I gave you a positive thing this week. How about that?
I'm impressed. And I'm also impressed that you are done now with Spanish 2, right?
Spanish 2, CC terminé con I always said Spanish.
Yeah.
Español dos. Yeah, so now I need to do a little review because it's really, for an English speaker, the challenges, as I know I've spoken to you, the challenges are things like the gender thing is not a big deal. You get used to that. What's challenging is words that end in MA, like problema. You would think that would be feminine, but it's actually a masculine word. Yeah. Because it ends in an MA. I have to pound that stuff into my head and just say it over and over. I will be using the thing that I made where I'm actually using technology to make a verbal recording that I can listen to. It's very, very cool. But I am excited to move on to Spanish 3. And
Yay!
Are you dragging with me?
It's helpful. I used to be pretty good at Spanish because I took it in high school, and then I lost everything. I can order things off a menu, but that's about it.
Right. So I think it's time for the news of the week. This one is frustrating. We'll do a frustrating one first and then some good news about a vendor. Yeah. Let's talk about this 1Password hack. And it frustrates me for many reasons. One is we're such a fan of password managers. And there are those who are not fans of password managers. There are also those who are not fan of the cloud.
Yep.
And this just is both of those things. So do you want to talk a little bit about the 1Password / Okta hack?
Yeah. So basically what happened is 1Password, I don't know if it was 1Password or Okta, but basically some hackers got into 1Password. They were able to change some things in their Okta instance and try to get a list of admins, which I'm sure they were going to use to target and be able to deploy things so they could cause bigger damage. And right. But as they were starting to sort of peel back the onion and figure out, okay, what happened, they realized what actually happened is it started on the Okta side.
Right. The reason they were able to do what they ended up being able to do was because Okta had already been hacked.
Yeah. And so it's interesting in this case because it wasn't like, oh, they just got into Okta and then they ping-ponged and got into 1Password. They actually looked at support files that someone in 1Password, an engineer, had uploaded because they probably had some issue or something else like that. They were reaching out to Okta and they uploaded basically a support bundle. And in that support bundle, they contained, in addition to sort of like information needed to troubleshoot, it also contained session cookies.
Right. Which they were then able to use. Right. Yeah.
Yeah. And so they were able to basically impersonate the 1Password employee and log into the system. And that's when they started causing havoc.
Yeah. And the good news is that that 1Password did see what was happening. They did see this weird session coming from an odd IP, and they shut it down before. Basically, all they did was attempt to get a list of admins. They didn't actually get the list of admins, is what it looks like. But the whole thing was, again, it went back to this the fact that the hacker initially had compromised the the Okta support system, which they then got this support file. And, in retrospect, it looks like everybody did their job. It looks like, right, that things were noticed, things were stopped. I think that in the case of Okta, maybe they weren't noticed quick enough because it actually, 1Password was just one company of several that were compromised because of this. It doesn't appear, for those of you that are 1Password customers, it doesn't appear that any customer data was accessed. Doesn't appear, unlike what was the other one? The LastPass? The LastPass hack, where they actually got the vault and then you had to worry if you had insecure passwords, right? That they were guessable. But it doesn't appear that that was the case here. They found it pretty quickly.
I think another interesting thing that I found, by the way, this is an article on the Register. We'll put a link in the show notes description.
Right.
The one thing I found interesting is they were trying to figure out, okay, what actually happened? Like, when was this information stolen? And so they went back and they looked at their logs on the Okta side and they were trying to figure out, okay, was the archive accessed before the support engineer on the Okta side accessed it? And they were able to figure out, no, the support engineer hadn't opened it yet. So it wasn't a rogue support engineer on the Okta side. And then they looked at the 1Password side, and they saw, okay, the person who uploaded it was on a public Wi-Fi at a hotel. And they're like, oh, maybe it could have been stolen during the upload because, those connections are always unencrypted and all the rest. But they looked and they're like, no, the upload process had TLS end to end up to Okta. And so everything was encrypted. It wasn't stolen in the process. So there must have been something else that had accessed it on the Okta side. So it's interesting how they're able to piece this all together. It's almost like CSI, right? You're piecing together all these clues, trying to figure out, okay, what happened, what went wrong.
Well, that's what you have to do in an incident response system, right? You've got to, piece together what you can from the logs that you have. Logs, right? That's what it's all about, is the logs. The only thing that's somewhat distressing is that it appeared that they made some tweaks, some upgrades to their MFA. And by upgrades, I mean like they changed some of their stuff. They're like, maybe we shouldn't allow anyone to log into Okta who isn't at a 1Password IP, right? Maybe we shouldn't allow that. That seems like
that's
maybe you should have decided that before, but
I don't know about that, Curtis, because there are times like you might be traveling and you might be the super user and you have to change something and you're not at a desk. Or imagine that 1Password blows up. Something happens to their site and they need to reset passwords and they could eventually get locked out. But maybe this is an exception case.
Yeah, I would think that would be an exception case that you would deal with. That maybe by the default would be that you would turn it off. The other thing was that it appears that now they're using YubiKeys. For those that aren't familiar with that, YUBIKEY. This is a hardware token. It's pretty inexpensive as these systems go, but it is a hard, it's an actual system that you can actually buy for your own personal use. I took a look and I think it was $100 for two of them.
And you want two,
and you want two. Yeah. And so, and so it looks like they're now using YubiKeys where maybe before they weren't using YubiKeys. I'm glad that they made those steps. It's just a shame that we always make changes to systems after we've been, after we've had an exposure. But good on them. Good on them for finding it. Good on them for responding and saying, hey, we could make this better. I'm a little dinging Okta here. There was a thing at the end that Okta basically said that perhaps if you're sending a support file, what was the type of that file? A HAR file?
Yeah. It's like an HTTPS sort of archive file. Yeah.
Yeah. And they're like, perhaps you should sanitize that before you send it to us. And I'm like, well, maybe your system that creates the HAR file should sanitize it for the customer before you upload it. There was a little bit, I thought, of victim blaming towards the end there, but Anyway, I think one that's going to be a lot easier to talk about. Our former employer, Druva, the headline here, it's a Tech Target article that they've added a Gen AI assistant to their cloud backup tool. And I watched a video of a demo, and it basically it looked like an NLM that you can use to interface with the Druva Cloud platform. And so you could ask it things like, "Hey, show me my backups." Like hey,
Natural
show me my
language.
backups have failed.
I think the big thing is, especially with the sort of focus on AI and making it easily available to a large audience without needing to know all the training, right? And being an expert in it, I think has now made it sort of commonplace, right? It's easy to pick up an AI model that has been pre-trained and use it for some purpose.
Right. In their case, they're using Amazon's. No great surprise there. They're using Amazon's NLM model.
Are you referring
and
to?
It sound like
sorry.
What?
Are you referring to NLP or LLM? You're calling it NLM.
Thank you. Oh yeah, sorry. NLP. Thank you. NLP. So they're using Amazon's product to do this. No great surprise. Druva lives in Amazon. And it seems like the biggest thing that they had to do was to make sure that it was integrated with the security features of the product.
Biggest thing that I see is, you have to make sure, because if you just pick up any random LLM, I'll use LLM because that's a large language model, right? Which a lot of the AI models are built on top of. If you pick that, and depending on what it's trained, you might get back bogus answers, random answers that aren't even safe. Right. And so at least the fact that Druva is putting guardrails in place to make sure that what gets returned is sensible and safe, I think is a good step.
Yeah, so we've seen AI use with Alcyon. We saw it with
Cohesity.
I'm trying to think. Yeah, Cohesity came out with one. Do you remember who else? It was Druva. I know there's another one.
Was it Commvault?
It's in the thing. Oh, Dell. Dell said, I don't think I've seen anything from Commvault, but Dell is also doing, I merged, I think, in NLP and LLM.
Into NLM.
It's a Curtis only thing. So, so that's interesting. I think anything that makes it easier to interface with your backup system is a good thing, as long as they have those guardrails in place and all of that.
And I know you always like to talk about how what's one of the most important jobs that you give to the most junior person at a company?
Exactly.
Backups, right? And so
why would you do that?
And so giving an assistant, if you will, right, to that junior backup person is helpful as they're learning the ropes.
Yeah. Well, that is the news of the week. As you know, every episode of the Backup Wrap-Up is going to dive deep into one particular topic. This week's topic is snapshots. Can I say?
Click.
It's a topic that comes up a lot. This word comes up a lot on this show. So it's time to dive deep into a world that I bet at one point in your career, Persona, you must have heard this word 100 times a day. What do you think?
At least.
Because there's certainly one company that thinks they do snapshots different and better than everyone else, and they're probably... They certainly at one point in time that was true. Yes. I think a number of other vendors are now doing snapshots the way NetApp did snapshots. So just a quick story to sort of bring why different ways to do snapshots really matter. I was at I'm in my brain live translating this story because I was at one of the largest companies in the world at a consulting gig, and we were helping them to pick a new storage and backup system. They were looking for an integrated system that would do both storage and data protection as part of that storage. They were already a NetApp customer, and they knew that meant that they knew every foible of NetApp. So they knew every bad thing about NetApp, but they also knew the good things. And I think of all of the consulting gigs that I've done throughout the years, they had done the best at presenting, these are our requirements, and they are well defined, and there are reasons behind every one of them.
Mm-hmm.
And one of their requirements was that they wanted end users, just regular Joe and Jane person sitting in the desktop, to be able to do their own restores, right?
Yeah.
And they wanted them to have the ability to do that at points in time that were like an hour at a time throughout the day, going back to, it was like 90 days. So specifically, they said, this is why we want 90 days of user browsable snapshots. At the time, that was like, not everybody did that.
Yep.
Right. Depending on how you did snapshots as a vendor, you either could or could not meet that requirement. Just end of story. And so the responses ranged from no problem, right? Literally no problem, to I remember one vendor coming in and going, that's the dumbest requirement we've ever heard.
I bet I could.
Why would you want 90 days of
is.
user browsable snapshots? Yeah, I think you know exactly who that was.
Yep.
It was just chaos.
Yeah.
And by the way, there was a vendor that came in and they had this. Let me restate that. I'm pretty sure it was that vendor that had this sort of very convoluted system that was based on, like, you had this block system and then you had this other system that had the blocks, and you could, it was just really, really complicated. And they had this wizard of a presenter that was just an amazing presenter that was very, charming and very smart, and just presented all of the stuff. And even though that presenter did their best, the customer just was not having it. And even though he was a really great presenter, it didn't fly. Anyway, the thing is that the key there is that how you do snapshots is it very much dictates how everything's going to work.
Going back to the requirements, right? You said that they had a very clear list of things. Do you know why they had that requirement for 90 days? Was it to, what was the purpose behind having that? Because I'm sure today everyone kind of thinks, oh, that's just reasonable, right? Oh, of course, why don't I have that? But back then it seeed like that was something very, very,
they had very specific numbers on the number of restores that had been done. And I know this as a backup person, but if you look at just all of the restores that are done ever, anywhere, for the history of restores, 99% of them are done from data from yesterday.
Yeah.
Right. And then, or from the most recent snapshot. And then there is this cliff of usage that just gets smaller and smaller. And it's just this incredibly ever increasing line to zero. And I think in their world, what they showed was that ever increasing line to zero basically dropped off at 90 days. And so they said, we need 90 days of user browsable snapshots. That's what I meant, was that they were really good at articulating what their requirements were, and also why those requirements.
Yeah. And I think that's a good lesson, though, for backup admins, right? You should be looking at the metrics of these systems, because if you want to make a case for, say, new technologies or new process improvements or other things like that, having this data to show why you need something so you can put it into requirements is critical.
Exactly. So let's define
what's a snapshot.
What we mean Yeah, what is a snapshot?
Let me give you my definition. Let's see how closely it aligns with what you call it.
All right, what's your definition of a snapshot?
My definition of a snapshot is a point in time copy of the data that existed at some point in time, so it has to have been plausible, that can be preserved such that it's not modified when the primary copy gets modified.
So I would take your definition and I would insert one word, I think, to make it perfect.
Okay.
And that is the word virtual at
Yes.
the beginning. Because it's a virtual copy, because that is really what differentiates a snapshot from a copy, because you just said a copy, right? So it is I like to use the word view. It's a view into your volume that you're protecting with the snapshot at a different point in time. And I like the word view because it which is very much a database term, right? Yeah. It's just it's a way to look at your current volume at a different point in time. I think the most important thing that differentiates a true snapshot from a lot of other things that we call snapshots is that it is a virtual copy, in that it relies on the primary volume that it is protecting for most of the blocks of data. The bulk of the blocks, when you're reading that snapshot, the bulk of those blocks are going to come from the current volume. Are you with me? Right?
Yes.
Basically, the change data is going to come from
the snapshot.
The snapshot, right? How that happens, that's the difference between copy on write and redirect on write. But the bulk of the data is going to come from the current volume.
Yes.
That's basically what I'm saying.
Okay.
Are we on the same page?
Yep.
Okay. All right. So we can go. I mean, only one of us actually worked at a vendor that did snapshots. So, I want to make sure I'm getting things right here. This is really the key of the difference between a snapshot and a copy, or a snapshot and a backup. Why does that matter?
Because
from a backup perspective, why does that matter?
Because if your source volume, something happens to it and it goes bye-bye, then you've lost your snapshots. They're not independent.
Exactly. And that's why, those of us that, care about things like backup and recovery, we just like to scream and say snapshots are not backup.
Yep.
Right?
Yep.
Now, I will say that you can use snapshots as a way to get backup, but a snapshot by itself on a volume is, I like to call it a convenience copy.
Yep.
Right?
Yeah.
It is a way to go back in time, as long as you don't have media failure.
Yeah.
Right.
Yeah.
Right. You don't have a double disk failure in a RAID 5 array, or a triple disk failure in a RAID 6 array.
Yeah. And like you were saying, it could use a snapshot to allow you to do other backup mechanisms, like take a copy, preserve it in a point of time. Now you move that data and you back up that data, right? Which, if you're integrating with applications, you can now take an application consistent point in time while your database is in hot backup mode. Take that snapshot. Now you preserve that point in time. You can thaw the database so it can continue operating like normal. Thaw the database.
What word are you saying there?
Thaw.
Oh, thaw. I don't know what word I thought you were saying there. So basically, you're saying, because you freeze it. Yeah. You're saying you freeze it and now you thaw it. Okay, all right.
Yeah, or you could quiesce and unquiesce.
Yeah. Okay. I don't usually use that term, so it really threw me.
Right, and then you do your backup off of that snapshot, right? So you now have a copy that's frozen that you can now do your backup, and it's all good to go.
Right. I'd say the most common, outside of storage arrays, the most common snapshot that is used in that way is VSS.
Yeah.
Right. The Windows Volume Shadow Services. And it's basically integrated into the operating system. It's integrated into the applications. It is and backup apps can integrate with VSS. These are all done with APIs, and a backup app can show up and say, "Hey, I am here to do a backup of this box. Please." I'm going to really simplify it. Please take a snapshot of everything that needs to have a snapshot taken of it before I take a backup. Then you take a backup, and then and it can take a backup of that snapshot, even though the volume continues to change.
Yep.
It's given this view into the volume that is static, and then it can back up that volume and get that perfectly application consistent version of the volume. Even if the backup takes 2 hours, it doesn't matter. All of the blocks will be from the same exact point in time. And then when it's done, it can tell VSS to delete that snapshot.
Yep.
Or it can keep it around. It's up to you. It's a configuration thing.
One thing I do want to mention that, like we said, snapshots just gives you that point in time copy, right? It's a read-only point in time copy. Now, sometimes you will also hear, and I don't think we're covering it later, clones being used, right? Where I take a virtual copy of the volume and start using it. Just going back to the previous discussion, Curtis, the difference is clones are writable. So you're making changes to it, right? A snapshot is a read-only copy that you preserve that point in time. Nothing's going to change it. And it's always there for you to go back. You could pull your file, your data out of it. Clones, on the other hand, give you a copy of the volume at a point in time, but it's so you can use it for some purpose, like for testing out restore capabilities. Can I verify my backups? Those sort of things. And also doing like database recovery against that copy, the clone copy, and other things like that. So clones are different than snapshots, even though they both might start from a snapshot copy.
Right. I would probably just call it a read-write snapshot, but maybe that's a contradiction in terms.
Yeah. Yes, a snapshot is a point in time, Curtis.
Yeah, exactly. There are 3 ways that snapshots are created. The most common way, would we say it's still the most common way, the copy on write method?
No, I don't think so anymore.
No?
Nope.
Okay. Well, historically, what used to be the most common method before one vendor ruined it for everybody.
Made something amazing.
So is called the copy on write method. And the reason it's called the copy on write method is that we create this storage area that is going to hold the snapshot blocks. And when we go to update a block, because it's a storage volume, right? So we're going to update a block and we say, hey, there's a snapshot for this block. We're going to copy that block out to the snapshot area before you write. So that's why it's called copy on write.
And that's expensive.
That is very expensive because if you think about it, there are, let me count, there is a read and a write for every write.
And it's not just the one read and write that happens on the snapshot side. You also have a bunch of metadata and updating indirect blocks and a whole bunch of other things. So yeah, doing a copy on write might lead to, say, 10 additional IO operations or 12.
Yeah.
Just for that one block.
And so what happens is that over time, that the number of blocks, remember when initially I mentioned that the bulk of the data is going to come from the primary volume, but over time, as a snapshot has been created, more and more blocks are going to be copied into that snapshot area, and which means that at some point, a significant portion of my snapshot, if I'm reading it, a significant portion is going to come from the snapshot area. And so there are multiple reasons that there's a performance hit. I think the biggest performance hit is, you talked about all of the IOs that have to happen every time we update, we do a copy on write. The other is that as time goes on, the more and more data that I have to get from my snapshot area when I'm doing a read, the performance goes down. And this goes back to that vendor that they basically suggested that if we had 90 days of user browsable snapshots, that their performance was going to be like half
Yeah.
of what
And,
it typically would be.
and I would say that is probably based on older technology, Curtis. I
Okay.
think when you had traditional RAID arrays or RAID groups that you were creating, I think there was more of a performance impact. I think now, since you end up aggregating a bunch of disks and then carving out volumes, and so you can share in the
Mm-hmm.
performance, I think that's not as big of a concern anymore as it used to be. Like, I know those systems you're talking
So you
about, they now support 1,000 snapshots, right, for a
so
volume.
you think that the main hit from a performance standpoint on a copy on write snapshot scenario in modern technology is mainly that IO hit the first time you go to do a write. When
Yeah,
every time
time.
you
Yeah.
update a write. And by the way, remember that it has to do that for every. It has to sort of calculate every time it does a write. It has to calculate, is there a snapshot that is looking at this block as it exists at this point in time, and then you have to copy it for that snapshot.
Yeah, which there are different mechanisms you could use. You could use bitmaps, you could use other things. So it's not the end of the world. And I think that a lot of these storage vendors have optimized if they are continuing to use copy on write technologies. But I would say a good
Right,
chunk of them have moved away from copy on write because of the IO penalties that we've talked about.
right, right. So the there was this vendor that came out, a little vendor called at one point it used to be called Network Appliance.
Yep. And it had a little
At some
screw and
point,
bolt as its logo.
right. The at one point they said we're just going to change our name to NetApp because that's what everybody
That's what
calls
everyone calls
us.
them. I remember actually
Yeah,
working at a startup and got my hands on my first NetApp appliance and was like, yeah, wow, these are kind of cool. And this was before I started working there. And I was like, wow, this
right.
is really amazing and simple for what it does and easy to use.
Yeah, exactly. And they used a completely different way to do snapshots that at the time was revolutionary, which I think has now been adopted by a lot of storage vendors. And that is, we call it redirect on write. Do you want to describe how that works?
Yeah. So before you get there, I think we need to talk about their write anywhere file layout, which allows then the snapshot.
Waffle.
Yep, waffle. Which a lot of other vendors I think do something similar as well these days.
Mm-hmm.
But what it is going back to the copy on write example, if you are writing a block of data in copy on write sort of file system, previous file systems, you would always write to the same spot. And because you're always writing to the same spot, that's why you have to first copy out the data and then update it. With a write anywhere file layout, what you end up doing is it doesn't matter which actual block you end up writing to. You basically construct the metadata tree to reference that block. So even though I might be updating block 100, block 100 might actually physically be at like block 1000. And because I have
Right.
all my metadata that tells me exactly where that data exists, I just need to update the metadata to say, okay, if someone tries to access block 100, it's actually physically on block 1000. And so you can end up writing to any location in the file system and not having to worry about always hitting that same location. And so that's kind of
Right. And
waffle
then,
in a nutshell.
so basically what you then is you have this metadata system that has a pointer to every block, and it doesn't really matter where those blocks happen to be.
Yep. And you
Right.
can have thousands of these snapshots, right? These pointers at the top.
Right. So then when we go to do an update and we have a snapshot, it just means that what we're going to do is we're going to change the pointer. We're going to say, okay, there's this block that's sitting here, and we know we're not supposed to update that block because we have a snapshot that's requiring that block. And then we're going to just redirect. We're going to write a new block for the new version of that old block, and then we're going to change the pointer, right? We're going to redirect the pointer to this new location of that block. Meanwhile, the old block is still sitting there, and we've got a snapshot that's just pointing to it.
Yep.
Right. And so you've got this infinite number of snapshots that are pointing to an infinite number of, well, it's not an infinite number of snapshots, but you have a very high number of snapshots that are and they're all just a whole bunch of metadata pointing to a whole bunch of blocks that are just sitting all around the volume.
Yep. And the one thing, so this all sounds amazing, right? Because you're like, oh, writes are super fast. I don't have to worry about it. In fact, Curtis, just one correction. When you're going to actually write a new block, you never actually have to look up the old block because you're always writing to a new location. So you don't care if that old block is occupied by a snapshot or not, right? Because this is the downside, though, of snapshots, especially with the write anywhere file layout, is you now need a process to go through and say when a snapshot gets deleted, what blocks are no longer being used actively because they don't belong to snapshots. They're not currently as part of the volume. So you have a garbage reclamation process, or different vendors call it different things, but some process to go through and reclaim all of those free blocks so they can be reused.
I think you said the same thing I said in different words, but yeah, I see what you're saying. I guess I was saying that it's making a decision on what to do based on whether or not. I think if I could just change part of my answer, instead of is this block being used by anything else, I guess is
more accurate.
I guess that's the question I'm asking. Yeah. And actually, I guess what you're saying is it actually doesn't even make that decision at that point in time. If it's going to modify a new block, if it's going to modify a block, it just writes a new block. And then what happens to that old block is a completely separate process. If there is a snapshot that's pointing to that old block, then it will stay. If there are no snapshots that are pointing to that block, then at some point the garbage collection process will come and make it go away.
Yep.
Is that a better description?
Yes, that is a better description. Now, this is specifically...
I don't want to argue with a former NetApp employee about how NetApp's work.
Now, I should say this is based on NetApp's technology. Different vendors may do different things, but for the most part, most of the vendors do something similar.
Specifically, it's based on how NetApp worked when you worked there, which was a while ago.
Yes.
And things may be different now.
Yep, that is also true.
Probably not.
Yeah.
I mean, Waffle is like at the core of their, the core of their technology. And so, and that's why with redirect on write, that's why you could essentially have an infinite number of snapshots with zero performance penalty. You have zero performance penalty of having basically the performance penalty of doing a write update is the same whether you have a snapshot or you don't have a snapshot. The only penalty, if you want to call it that, is that one big difference between this way and the other way is there is no snapshot area, right? So in the other method, the snapshot area could fill up if you held snapshots for too long. In this configuration, there is no snapshot area. The snapshot area is the volume. And if you have too many updates and you keep too many snapshots, you would fill up the volume with snapshots. So you've got to get rid of the older snapshots.
Well, and this is where that would apply if you're talking NetApp terminology, traditional volumes, but most of it has moved over to virtual volumes, where once again, you have an aggregate, a shared pool of common data. And for each of the volumes, typically you also set a limit on how much space a snapshot can occupy. So you could say, I am allowing 20% for snapshots of my overall volume capacity, in which case it'll start notifying.
And what happens when you hit that wall?
I don't know what the current behavior is. Previously, I believe it would let you start automatically pruning snapshots and trying to free up space.
Right. Because obviously it's not going to prune production, current data. Yeah. So it could, but again, we're talking specifically NetApp, but something has to happen, right? If you're using this method, something has to happen. Either we have to stop creating new snapshots, right? Or stop updating the snapshots that we have. Yeah. And we need to delete older snapshots, or we need to maybe delete certain ones in the middle, right? Basically, you've got to do some kind of pruning or else you're going to run out of space.
The other challenge is also figuring out what snapshot to delete because blocks are being shared, right? You might be like, hey, this snapshot is huge, and you go delete it. But because those blocks are being shared by other snapshots, you're not actually going to free any space, right? So you need to be able to figure out like which snapshot actually contains unique blocks that if I delete it will actually save me space.
It's complicated. Storage management. I don't miss production storage management. Any other final thoughts on redirect on write?
No. I think that covers it all.
I mean, if you're going to do snapshots on a storage array, I think redirect on write is the way to go. It sounds like what you're saying, they've made copy on write better, but I still think redirect on write is just significantly better. So, but it might be more complicated than if you're coding it, right? So the next one is what I'm going to call the dumbest of all snapshot methods. That's not what I have in the book. I gave it a much nicer name in the book. And guess who does this method?
The leading hypervisor company in the world.
Yes.
I think that's a fair statement, right?
Hypervisor company in the world. I think it still is, yeah. And that would be VMware. So the way VMware does snapshots is just literally the dumbest implementation of snapshots that I've ever seen, and I don't know how they haven't addressed it, but here it is. When you create a snapshot in VMware, it literally holds all the rights. Now, by the way, if I'm wrong, Broadcom, don't sue me. This is based on my understanding of VMware snapshots. I've checked every once in a while, and no one seems bothered by this. But if this has changed, any of you that are, if anybody who works for Broadcom/VMware, then, feel free to update me and I will update this episode and I'll just delete this section. But here's the way it works. When you create a single snapshot on a VMware volume, it halts all writes on the current volume. And then it keeps all writes in a snapshot area. And then when you delete that snapshot, it replays all those writes against the production volume. And this is why when you make a snapshot and then if you hold that snapshot for a long time and then you delete that snapshot, this is why it has a big performance hit against the production volume.
But no one ever takes a snapshot of a VM.
Yeah. This is why you do not do this. You don't use snapshots on VMware level snapshots the way you do any other snapshots. Because, and by the way, I used VMware for years before knowing this. That's why I want to make sure I mention it. And that is that if you create a snapshot and then hold it for a long period of time, you're going to get hit with a massive IO hit when you delete that snapshot. So if you're using VMware level snapshots, then you use them the way we talked about earlier, where you create a snapshot, you make a backup, and then you delete the snapshot. Maybe you take a VMware level snapshot and then you take a storage level snapshot of that snapshot, and then you delete the VMware level snapshot. You should, if this is the way your snapshot system works, you cannot leave the snapshots around for any significant period of time.
Yeah. I was going to chime in. Thank you for covering that. This specifically is VMware software snapshots, if you want to call it that, right? Yes. That are only done at the VMware level. Now, there are integrations that various storage vendors offer by plugging into the VMware API. So whenever you trigger a VMware snapshot, it actually triggers a storage level snapshot. So avoiding some of these issues, but not everyone is aware of it. Not everyone is using a third-party storage array that integrates with VMware. So just another way.
So right. Thanks for clarifying that. This is specifically VMware level snapshots that are done by VMware without any third-party storage.
Yeah, and I don't know why VMware did this, but it's bonkers.
It's just literally one of the weirdest coded things I've ever heard. Why would you do it that way? Somewhere in a meeting, this is how they decided to do it.
It was probably easier.
And yeah, maybe it was easier.
And they didn't talk to the backup
I
folks.
wonder about the. They did not talk to the backup folks. Well, I think we have summarized the world of snapshots. What do you think?
Yeah, no, I think we did a good job with that.
So copy on write, redirect on write, dumbest method ever. Those are the three types. I've got it officially in the book. I've got this labeled as the hold all rights method. I should really just change that to the dumbest method ever.
Don't do this.
But yeah, so snapshots are a great tool in the backup and recovery arsenal. They are the great sort of basis upon which we're going to talk about one of my favorite ways to do backup. And we're going to talk about that in another episode. Hint, it's called Near CDP, not CDP. It's called Near CDP. And it's just the number one thing you have to understand about snapshots is that unless you have copied this snapshot to another location via some mechanism, which could be backup, it could be replication of the volume, it could be a number of things, you do not have a backup. You have a picture of your volume, and that picture of your volume is as worthless as a picture of your house after your house burns down. Right? It'll just be a nice memory.
Yep.
And a really bad day. So that's really the most important thing to understand about snapshots. And now, if this is your first time snapshots have been explained to you, now you understand why I don't like it that they call what AWS does snapshots, because that very much does not meet the definition that we just had. And I'm glad I brought this up, because it's important that what we're talking about is storage level snapshots. Darn it. I don't know.
You can't call it that, yeah, because AWS.
These are traditional snapshots. There are other things out there that people call snapshots that don't work like this. AWS snapshots don't work like this. They are an actual image copy. It's actually when you make an AWS snapshot, it actually copies that point in time out to another area of storage, which happens to be S3.
Could you? And I think specifically you're talking about an AWS EBS snapshot.
Thank you. I am talking about an AWS EBS snapshot. My former employer, Druva, they call what they do snapshots. They call their backups snapshots. I never liked that, but nobody asked me. But what we're talking about here is traditional snapshots, and a lot of other people will call what they do a snapshot. The problem is, like a lot of terms in the backup world, it's a term. Like so many of our terms are they're words that are used. They're just English words that are used in so many different contexts.
It's
right?
when we had the CDP episode, we couldn't figure out what to call those point in times because a lot of the CDP vendors call them snapshots.
Yeah, exactly. Yeah, exactly. All right. Well, I guess the only thing left for me to say is that's a wrap. The Backup Wrap-Up is written, recorded, and produced by me, W. Curtis Preston. If you need backup or DR consulting, content generation, or expert witness work, check out backupcentral.com. You can also find links for my O'Reilly books on the same website. Remember, this is an independent podcast, and any opinions that you hear are those of the speaker and not necessarily an employer. Thanks for listening.